And welcome to part 2 of the proportional thinking video, and maybe you've got all that big mess down from the first video. We're going to go down and take a look at some of these examples over here. So the first one, you perform and, I don't know what word we should put in there, develop a mathematical model. D is equal to 2 meters per second times time, where d is the distance traveled in meters and time is in seconds. And hopefully you're getting used to the fact that often if numbers include units, then we include the units in the equation. So this would be like our k value when we're talking about things. So my first question for you is, which graph above shows that relationship? So looking at it, hopefully you can see that it would be graph D. So if I were to sketch out a quick little graph D, it looks like this. Instead of using y versus x, now this would be my D for the distance, and it would be in meters, and this would be t, time, in seconds, and there would be the graph, and this 2 business, that's the slope, equals 2 meters per second. Isn't that cool? All right, so another way we could just quickly say then, that one is d is proportional to time. Distance is proportional to time. Or you could say d equals k times t, again, where that k is the 2 meters per second. Regardless, moving on to the next question, if we're to double the time, so what does double mean? So double means times 2. If we're double the time, it's over here, if we're going to say times 2, then what would happen? This would just get multiplied times 2. So if we double the time, what would happen to the distance? The distance would double. So for part A, if t is doubled, then d is doubled. For part B, I don't want to write it all out. If the time is tripled, then the distance is tripled. D is also tripled. Okay, so that's how you could answer that. Pretty straightforward. Okay, moving on to the next page. Now, the same toy car that you'd done all this work with, and you'd figured out a mathematical model for the motion of it, your friend, in quotation marks, takes it and drops it out of the window. Oh my goodness, so I don't know, so here's a building and here's the window, and they drops it and it falls there. And now it does not move in the same way, does it? Now this is the relationship of its motion, and it cost 1 toy car to figure out that relationship. Which of those graphs would show that relationship? So take a look at A, B, C, D, and E, and which one would fit with that? Can you figure it out? Well, I think it would be the one that shows, I think it's letter B, but it's the one that looks like, I'm going to go back to a nicer color, one that looks like this, right? So the parabola one. Parabola. So because this is the k part, and it would be the one where y is equal to kt squared, or you could just say y is proportional. Oh, actually, I'm getting mixed up. I could either say an x here, y is equal to kx squared, or I could use our examples from this one where it'd be d and t. So now I'm making you erase. So I'll go back and I'll make this specific, or I could say d is proportional to t squared. All right, does that make sense? In words, you could write the distance is proportional to. Again, I'm shortening the words. So this symbol here really means is proportional to t squared. So what does this mean? I'm not going to use all this stuff in red over there, but I'm just going to do the really quick and easy one to say, well, if I were to double the time, in other words, if I was to double this times 2, what's going to happen to that? Now, in our previous question, it was just directly proportional to, and there was no squared or anything like that, and if I doubled one, the other one doubled. Now, in this case, if I doubled time, now looking at this, see, if it doubles, you can see it more than doubles, right? This one actually gets multiplied times 4. Okay, so if I mathematically, if I wanted to prove that, I could do something. You don't have to write this down if you don't want to, but I could compare the old situation with the new situation. Old I got in green, but just to emphasize, I'll put O and O here to mean old, and I'll just put and new here and new here. So the old distance was equal to 5 times the old distance, or old time squared, and the new distance is the 5 times the new time squared. Okay, so one thing to realize is that we're doubling the time. So in other words, if I double the time, that means that the new time is equal to 2 times the old time. So if I go over here, I can say that the new distance is equal to 5 times, instead of the new time in there, I'm going to put 2 times the old time all squared. Now when I square this, I'm going to say the new distance is equal to 5 times, this entire thing gets squared. So I'm going to say times 4 multiplied by the old time squared. The old time squared. Now, if I rearrange this, and I'm going to put this, here's a 5 times 4 times t squared. I'm going to put the 4 out front, times 5 times the old time all squared. And now I'm going to point something out, is that this is the same as this. So in other words, here we can say the new distance, we'll get this figured out, the new distance is equal to 4 times, now I'm going to insert, instead of writing 5 times the old distance squared, or 5 times the old time squared, I'll put times the old distance. So this is a long mathematical sort of way of showing when I put the 2, when I put this 2 in here, it gets squared with it. So this is showing that the new distance is going to be equal to 4 times the old distance. If you like this purely mathematical, abstract way of looking at things, wonderful. If not, you can see the pattern. If I'm multiplying this time times 2, because of that squared, it's also going to be squaring this times 2. All right, what about this next part? What about triple? If I were to triple, and I guess I would need I don't know, I'll write it out again. I got d is equal to kt squared. Now, if I'm going to triple the time, times 3, what's going to happen to the distance? It'll get multiplied by 9 because it's times 3 squared. Okay, that makes sense. Hopefully it does. Example number 3, which graph shows the relationship between mass and period in your pendulum lab? Well, hopefully you'll remember in your pendulum lab that when you graphed it, this could have been period, and this could have been the mass, or perhaps you used the word weight, I'm not sure. And it looked something like that, and this was in seconds probably. What would the mathematical model, oh, so this one was no relationship. This is what we call this one. What would the mathematical model, what would the formula look like? So if we use P for period, P would be, now there's no, like if we think y equals mx plus b, this slope is 0. So if this, this m or that k value, if that's 0, then this whole thing turns into 0. So y is just equal to the y-intercept. So in this case, we don't use y, we're using p for period. It's going to be whatever value that was. And so it's going to be some value, or we could just put 1 in. I think when I did it in class, maybe I got, I don't know, 2.6 seconds or something. That's what the formula looked like. The period, switches back to period. The period was some constant of 2.6 seconds. If I were to double the mass, well, here's one mass, and here's double that amount, the period stays the same. What would happen to the period? Stay the same. Okay, example number 4. Your class has been asked to stack all the chairs in the gym after a concert. If you were to compare the number of students, number of students, let's pick a letter for that. I'm going to call that one, say N, with the time it takes to finish, and perhaps we should do T for that. Okay, which one is the independent variable and which one is the dependent variable? Which is the one that we get to pick? Well, we can choose the number of students. n. And the dependent variable, the one that depends on the number of students, that would be time. So if we were to make a graph, where this would be the number of students, n, students down here, and here would be time. I don't know what would be suitable units, probably minutes, not seconds. Okay, let's think. If we were to get more students to help to put away the chairs, what's going to happen to the time? It would actually decrease. What happens if we increase the number of students? Decrease in time. So what would the graph look like? Which graph? I'm actually answering that over there. I think it would end up being this one, wouldn't it? Okay, so we could do, I'll do it again, t and n could be here. Or we could also graph the linear version, t versus 1 over n, and then we would get a straight line. Both of these graphs work, okay? So we could say in terms of proportionality, t is proportional to 1 over n. In the mathematical model, we could say, well, t is proportional to 1 over n, but we could also say t is equal to some constant, whatever that slope is, times 1 over n. Or we could say t is equal to k over n. Either way would work. Okay. So let me ask the question. What would happen if we were to double the number of students? If I were to say here times 2, if we were to double the number of students, what's going to happen to the time? Well, so looking at our graph, if we, moving that farther out, we can say, here the time actually decreases. Hopefully you're getting a sense of the pattern here, is that since this n is in the denominator, since it's proportional to 1 over n, the same thing is going to happen to my factor, the thing that I'm multiplying by. If I multiply n times 2, this time is going to get multiplied by the reciprocal. It's going to get multiplied by 1 over 2. Okay, let me pick another example. Let's say if I were to multiply this, if I was to say, hey, what happens if I have 1/3 as many students? What's the reciprocal of 1 over 3? Then it would take 3 times as long. I would multiply the time by 3. If I had 0 students, then it would take an infinite number of time, or it doesn't really make sense. Nothing would happen. And mathematically, if we divide by 0, we get an error. That's kind of cool. Okay, example number 5. Here's a relationship. And we can either say, and I mentioned earlier, y squared is equal to kx, or y is equal to k times the square root of x. If I was to graph this again, I could use y squared versus x, and I would get a straight line, right? Or I could also do y versus the square root of x, and I would also get a straight line. So another way we could write this is we could say y squared is proportional to x, or we could say y is proportional to the square root of x. Okay, and they both have their uses. So in terms of proportional thinking, if we multiply x by, let's pick a number, let's say if we multiply x times 4, then y is going to be multiplied by. So for this one, I think it's easier to pick this one here. If I multiply this times 4, there's a square root sign over it. So we need to do that to our times 4. So what happens when we take 4 when we find the square root of it? Y is going to get multiplied times 2. Let's see if that makes sense. Okay, let's pick, 1, 2, 3, 4. So here's, there's my 1x, and if I multiply it to x times 4, it goes all the way over here. So y kind of doubles. All right, hopefully that makes sense. Another way, y is multiplied times 2. If we think of it over here, we almost have to look at it backwards. If we multiply y times 2, then moving the other ones, then this x is going to get multiplied by 4 because it's got that square sign over it. So in either case, we get the same result. For a certain moving cart, v squared, how fast it's moving, the velocity, is going to be equal to some constant times the energy kinetic energy. That's what this stands for. So that's one way of writing it, or you can write it this way too, with the square root of both sides. So both of those mean the same thing. We're just square rooting both sides. If we're to double the kinetic energy, if we're to multiply this times 2, what would happen to the velocity? Well, whatever we're multiplying by, we have to square root it. So this is going to get multiplied by the square root of 2. What would happen to the velocity? It would get, the new velocity would be, it would be bigger, but it would be multiplied by the square root of 2. By the way, the square root of 2 is approximately about 1.414, I think. So it would increase, but it wouldn't double, right? It would go up by some amount, but not totally double. Okay, here's some proportional thinking practice. Is it just that one? Oh, maybe there's more than just that one page. Let me just check here. Yeah, so I've got 5 questions on my page, and then there's 6 and 7. So, and then there's answers there. So state what happens to y. K is a constant, and this is the symbol of proportionality. So if x is tripled, I'll just give you the first one. Y is also tripled. Or more simply, you could just say y is multiplied times 3. All right, I want you to try this practice. If you got any questions, please ask me in class. See you in class.